So, good morning, guys. I hope you all had a wonderful weekend. Today, we will be talking about Module 4. Module 4 is the physical layers. If you can remember, we talk about the OSI model. The OSI has 7 layers. Probably we will be seeing these layers and we talk about them in more details. The layers start from the physical layer. We have the data link layer, the network layer, and the session layer, the transport layer, and the physical layer. Sorry, application layer. Okay? So you need to know all this. So here we're talking about the physical layer. This is the physical connection. This is the lowest, the last level. That is the physical connection that happened. That means the cables that you use to connect, to transmit signal, or the wireless medium, that is the physical layers. And in the cables, this data is turned into electrical pulses, into ones and zeros to be transmitted over the physical medium. So before any communication can occur, or before any communication can take place, physical connection to the network must be established. Okay, the connection can be either wired or wireless. You know, we all know that. So if you look at the wired connection at the back of your computer, you'll have a NIC card, that is the network interface card that you use to connect your cables to. You know, some devices may have one NIC, while others may have multiple NICs. You know, generally, pardon? Okay. Generally, our computers will have one NIC, but you can have more than one network interface card on your device. Not all physical connections offer the same levels of performance. Like there'll be difference in performance if you use wireless and wired or use fiber cables. So there is obviously difference in performance. Right. So the physical layer, it transports the bits, like I said, it transports the bits across the medium. Okay. It accepts a complete frame from the data link. According to the OSI model, the frame from the data link layer will be transferred to the physical layer for the transmission. If you look at this diagram here, you have the web server and you have the web client. So this data will be sent through this physical medium you're seeing here that interconnect them. Physical layer characteristics. Right. Guys, this is the OSI model. You can see here, physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. This is the complete model. Okay. So if you look at the physical layer here, it says the physical layer standards are implemented in hardware and are governed by many organizations. Like the physical layer devices, like the cables, there must be standards that every cable manufacturer must follow. Okay, there must be standards that every cable layer must follow to manufacture physical layer devices. Physical components. Physical layer standard address 3 functional areas. It addresses physical connection, it addresses encoding, and it also addresses signaling. I'm getting noise. Seth, can you mute yourself? Hello, sir. Okay, so it addressed 3 components. You can see the encoding component here. Encoding converts the streams of bits into formats recognizable by the devices. Encoding provides predictable pattern. You can see this is an encoding pattern here. Okay, let's take Lamin. This is an encoding pattern on the medium that the data is converted to zeros and ones to be transmitted on the physical medium. Okay. So you can see the signaling methods here. There are different kind of signaling methods when we use the optical fiber. These are the microwave signal patterns that you will see. Or the electrical signal over copper. Yes. Okay. Lamin. So we have measures for bandwidth. The units of bandwidth is bits per second. You have bandwidth. Okay. The units for bandwidth is bits per second. So the fundamental unit is 1 bits per second. Then from bits per second, you go to kilobits per second. 1 kilobits per second is equals to 10 raised to the power 3 bits per second. 1 kilobits per second is equals to 1,000 bits per second, 10 raised to the power 3 bits per second. Then from kilobits per second, you go to megabits per second. 1 megabits per second, 10 raised to the power 6. That is 1 million bits per second. Then you move to gigabits per second. 1 gigabits per second is equal to 10 raised to the power 9 bits per second. That's how it goes. Then you have terabits per second. So the unit for measurement of bandwidth is per second.
Uncle Yanko.
Yes.
Uncle Yanko.
Yes, sir.
We have a lot of noise under the background.
Yeah, this is GRTS.
There's a lot of noise under the background.
Sure. Sure. So next is we talk about cabling. We have different types of cabling. Characteristics of copper cabling. Okay. Copper cable is the most common types of cabling used in networks today. And it is inexpensive, easy to install, and low resistance to current. Okay. So this is what we normally see in your offices, connecting your laptops to switches. That is a copper cable. It also have different characteristics. That is attenuation. The longer the signal have to travel, the weaker they get. Like a copper cable must also have a limited distance. Like if you are running a Cat6 cable, it is recommended that when the distance is more than 100 meters, it's not advisable to use it. So because it says the longer the signal travel, the weaker it gets. That is the signal attenuation. You also talk about electrical signal in a susceptible or interference. There can also be what is called EMI, electromagnetic interference, in the cabling. So how do you mitigate these problems? How do you stop these problems? Okay, mitigation is you have to strictly adhere to the cable limit. If the distance is more than If the distance is more than 100 meters, you don't use it there. Some kind of copper cable mitigated EMI or RFI. That is a copper cable that comes with an aluminum foil sort of. You will see it. Some kind of twisted pair cabling. There need to be some twisting so that you can avoid what is called crosstalk. Okay. So this is an example of different types of cable, guys. Are you seeing? We may say this one you're seeing. This one is an unshielded twisted pair, and this one is a shielded twisted pair. And this is an example of a coaxial cable. Normally, those who work on satellite or install these TV antennas, these Yagi antennas, This is the type of cable they use, the coaxial cable. Okay, you have a unshielded twisted pair, you know, and then you have the shielded twisted pair. You can see the shielded twisted pair. It comes with a sort of an aluminum foil that is protecting the cable. Can you see it? It comes with a sort of an aluminum foil that covers the cable for protection. And this aluminum foil can also reduce electromagnetic interference. Okay? So this is an example of the different category cable. This might be a Cat 5 or Cat 3 cable. So the unshielded twisted pair, you can see that twisted pair, I mean, cables are twisted together with different colors. You can see this one is a white, orange, and orange. It's twisted together. So this twisting helps to minimize crosstalks between the cables, okay? You can see this one is white, green, and green. They are twisted together. This one is white, blue, and they are also twisted together. So this one is the shielded one. You can see it has more protection. Like I told you, this number 2 is the shield, sort of an aluminum foil that protects the cable. So it has more protection to reduce electromagnetic interference and also to reduce crosstalks. So this one is
by
the
crosstalks.
Mm-hmm.
What do you mean by crosstalks?
If you are conversant with the conventional telephone systems, I know most people don't use them in your houses now, but before you realize that normally in the rainy season, you may have a call on your landline, and whilst you are talking, you can hear somebody also talking to somebody else in the background. I don't know if you have ever experienced that. Hello?
Yes, okay. We're getting it.
Yes. So those are the kind of things, because you know, when these cables are carrying signals and they happen to have some contacts, you know, these signals are transmitted using some minimal electricity. There are some electrical pulses that travel through them. So if they have that contact, there can be that crosstalks that can happen in place. So that's an example of it. Normally, people don't use the landlines, because these are the same type of cables the land phones will use. So even in your
crosstalk, is it the same as short circuit?
Yeah, it could be. It could mean short circuits. Yes,
okay.
In electricity. Okay. Yeah.
Hello.
So there are different types of connectors that you use. I mean, these ones I'm not very familiar with, but I know my friend who is a satellite technician. He will know all these connectors a lot.
The first one is BNC. It's the British Naval Cable. We use it here for SDI connections.
Okay, perfect.
Yeah, that is what we use to send video and audio signals.
Okay, perfect.
Yes, the BNC is British Naval Cable. I've not been using these two, but this one, the first one we're using, the first one, BNC.
Yeah,
this is a BNC connector.
Okay.
And this one is even N-type, I think is the coaxial type.
Yes,
coaxial, yeah, the one we use in our antennas, TV.
Okay.
Yes.
So those who do this satellite and other radio signaling will know a lot about this type of connectors, but they are mainly used to be connected on coaxial cable. Like I told you, this coaxial cable is mainly used. I used to see them with people who do this television antenna installation and satellite installation a lot.
In CCTV.
CCTVs, yes, but you know now CCTVs also use this this category cables, like these network cables. They also use CCTV cameras now. I understand previously they used these ones, yeah. So the unshielded twisted pair cabling. Okay, this is an example of properties of
the second week.
Pardon? This is the okay. This is the unshielded twisted pair cable. You can see we'll talk about color coding. I mean, each pair is twisted, like I told you, to avoid crosstalk. You can see it's here. UTP relies on the following properties to limit crosstalks. Cancellation. Each wire in a pair of wires uses opposite polarity. one wire in negative, the other wire in positive. Okay. So
yeah, some people are waiting to be admitted, please.
Okay, let me check. Sorry. Okay. Sorry, I have to go back. So these are the properties of the cable. It's one of the properties is it has the capability to minimize EMI or RFI. RFI stands for radio frequency, I think, interference, and EMI is electromagnetic interference. All this can happen because among ourselves, we have a lot of radio signals that travel, a lot of signals, around you. So all this can affect the performance of your cable. Variation in twist put in each wire. Each wire is twisted a different amount. You have the twisting also has, there's a different amount. Let's say per meter, you have a number of twists that can happen. This helps to prevent crosstalks among the wires in the cables. If you look at some cables, they are more twisted than the other. But this twisting helps a lot in trying to minimize crosstalks and EMIs. So if you look at this, let me minimize this. Okay. Like what I was telling you, you can see the different category of cables. This is a category 3 cable. This is a category 5 and category 5 cable, and this is a category 6 cable. Okay. So, we will look at all these categories of cables and their connector types and the terminations. So these are the terminations. This connector here is called an RJ45 connector. RJ45, RJ stands for registered jack. It's an RJ45 connector that you use to crimp the cable with. You can see they're trying to crimp the cable with it here, But this type of termination is a poor termination. They said it's a poorly termination because the insulator and the tip of the connector has a gap. This is a poorly terminated one. If you are terminating it, at least the insulator should be inside the head of the RJ45 connector. You can see this is poorly terminated, but this one is properly terminated. So you have the RJ45 head, you can see, but there are different types of connection. Sometimes you walk into some offices, you'll find a socket there, just like your electrical socket, where you can bring your cable head and connect it. So that is an RJ45, sorry, that is an RJ45 socket. You can see the socket is open here. You can put your cables, connect them to the socket, and then somebody is going to bring the RJ45 connector and connect it there. So there are different ways of connecting this, different ways of connecting it, or termination. The first one you are seeing here, there is a straight through. There's something called straight through and crossover cabling. Okay, straight through cables and a crossover. Where do you use straight through and where do you use crossover? And the third one is called rollover. You can see it here, rollover. You have straight through, crossover, and rollover. Straight through cabling, if you are connecting unlike devices, use a straight through cable. That's a simple explanation. If you are connecting unlike devices, an example will be if you are connecting a switch to your laptop, you have to use a cross through cable. Is that clear? If you are connecting a switch to your laptop, you have to use a straight through cable. These are unlike devices. If you are connecting your router to the switch, you have to use a straight through cable because they are unlike devices. Is that clear?
Once more, please.
Okay, straight through, you use straight through cables if you are connecting unlike devices. That is, if you are connecting a switch and your laptop together, you have to use a straight through cable because these are unlike devices. Okay, that is why you can see here, they said application is host to network. That means you are connecting a host device to a network device. A switch is an example of a network device. Your laptop is an example of a host device. Okay, but there are two types of straight through termination, that is T568A and T568B. You can see them here. These are the two types of straight through. Okay, but normally in most cases I use this one, the B type. So you need to understand this cable later on. If you are terminating a cable with this T568B, first you choose a white orange, white green, blue, white blue, green, and then white brown and brown. So that is T568B. If you are using the A, you start with white orange, white green, white orange, blue, white blue, orange, white brown, and brown. So these color codings, you need to by heart them. You need to know this offhand. You need to try to crimp cables as much as you can so that it can stick to your memories. You need to understand this cabling. Okay, that is all for straight through. The crossover, if you are terminating crossover, use crossover to when you are connecting like devices, similar devices. That is, you are connecting a host to a host. They are similar devices. That is, you want to connect your laptop to another laptop with a cable, you use a crossover cable. Okay? If you are connecting a switch to a switch, you use a crossover cable, or you are connecting a router to a router. So these are like devices. So the last and the final one is a rollover cable. This is Cisco proprietary. That is, if you want to connect your laptop to the console port of a router or a switch, to the console port, that is the time you use a rollover cable. Is it clear? Guys? Hello?
Mr. Youngs.
Yes?
Yes.
I said, is it very clear? Are you okay with this cable?
Yeah, that one is okay.
All right. Now we move to fiber optic cabling. Right. There are different types of fiber optic cables. I don't know if you have ever seen fiber optic cables, but I mean, okay, we will learn about.
Yeah.
Yes.
So, but we saw it, but we've never used it before.
Okay.
We use it in our systems, but we've never, applied this fiber thing.
Okay. These are the properties of the fiber. I mean, not as common. It's not as common. That is why. Okay, one of the properties is not common. That is why not all of us have seen it. But the UTP cables, I believe everybody have seen that. So the fiber is not common because it is very expensive. Ideal for some networking scenarios, like if you are building network topologies of a greater distance. Okay, it transmits data over long distance at higher bandwidth. Okay. It is also less susceptible to attenuation and completely immune. Okay, distance doesn't disturb it, and it is completely free from EMI. It is more flexible, extremely thin, and it uses LED to encode bits, and then it travels at the speed of light. Okay, fiber cables act as a waveguide to transmit light between two ends with a minimal signal loss. So you have two types of fiber cables. You have the single mode fiber and a multi-mode fiber. Okay, you have a single mode fiber and you have a multi-mode fiber. It says a single mode fiber, very small core. You can see the diagram here. Inside, you have a core inside. So the single mode fiber has a small core, while the multi-mode fiber has a larger core. Okay, then it uses expensive lasers. It uses expensive lasers, and whilst the multi-mode also uses less expensive LEDs. Okay, the single mode fiber can take care of longer distance, but the multi-mode fiber can also take care of 10 Gbps over 550 meters. So these are the differences between the two. These are the two main types of fiber, single mode fiber and then multi-mode fiber. Fiber transmit data at the speed of light. It is very fast and it can carry huge bandwidth for you. Gamtel uses fiber to interconnect all their exchanges in the country. I mean, there is a fiber that runs from Banjul here up to Koina. And within that fiber, I think they also send GRTS.
Another machine wants admission, please.
Pardon?
Another machine wants admission.
Okay. Right. Gamtel has a fiber backbone in the entire length and breadth of the Gambia, already an existing infrastructure. So if anybody needs to interconnect two different places in the country, you don't have to take the trouble of running your own fiber now. What you need to do is you just get to Gamtel, they help you transport your data through their fiber. Even GRTS radio and television broadcast, some of them, I think, I don't know, most of them, I think they are using the Gamtel fiber from Abuko here to Bonto and then to other parts of the country.
But don't market for Gamtel. You know, but you are marketing for Gamtel. Take it easy, yeah?
Okay. And even most of the banks, for them to be able to interconnect their branches, let's say Standard Chartered Bank head office in Banjul and Standard Chartered in Basse, they have to come through Gamtel because Gamtel has an already inbuilt fiber infrastructure because it's not easy. GRTS cannot run their own fiber from Banjul to Koina. It's going to cost them a lot. So before you take that cost, you just go to Gamtel and pay them small money. They carry your traffic for you. So optical fiber cabling usage, you have the enterprise network, you have fiber to home, you have a long haul network and submarine cable networks. These are the different types of industry networks. The enterprise network used for backbone cabling application and interconnecting infrastructure. That is an enterprise. I'll give an example of Gamtel network as this enterprise network. It's used for backbone cabling, that is to interconnect different exchanges in the country. You also have fiber to home. Recently, Gamtel has launched this fiber to home. That is our GPON. I don't know if you know about the GPON network, or they call it the ECO1 network. If you go to some various households in the greater Banjul area, now they are using fiber in their premises. That is called fiber to home. You know, sending broadband services to homes. You also have long haul network used by service providers to interconnect countries or cities. That's our long haul networks. Let's say if we have a branch in Gambia or Banjul at Dakar, we want to interconnect them, we can use long haul network. We also have submarine cables. I'm sure we all hear about this ACE submarine landing station. You know, it uses fiber to interconnect different cities together. So these are all done by optical fiber. Right. Fiber also has different types of connectors, just like copper cable, I mean, where we talk about the RJ45 connectors. Fiber also have different types of connectors. You can see the straight tip connector, and you can also see the lucent connector here. And then you have the duplex multi-mode connector and the subscriber connector. These are the different types of fiber connectors, just like the RJ45 connectors. I mean, I think we are running out of time. Okay. Just like the different types of connectors.
Youngs, which one is more common in the Gambia? Which one? Youngs.
Yes.
Which one among these ones are?
No, all these things are being used in the Gambia except this straight tip. But if you look at all this, you use them in the Gambia here to connect it to different machines. Like you don't even need a long distance cable. These are called fiber jumpers. Small fiber with some are red, yellow colors and brown colors that you use to interconnect your machines. The way you interconnect using
you go to the transmission room.
UGB cable.
Transmission room, it's there.
Yes, mostly you can see these are called fiber jumpers. You can see, so you use them to interconnect different machines. You don't need a long one for that. These are called fiber jumpers. How many more slides we have? So these are the difference between fiber and copper. I'll share the slides with you. You can read them, the difference between fiber and copper. You can see copper UTP starts from at least 10 megabits per second to 10 Gbps. But fiber from 10 megabits per second to 100 Gbps. So the distance, relatively, copper will take care of 100 meters. Fiber can go up to 100,000 meters. You can see the difference. So you can go through all these differences. How many meters? So wireless media, we have different types of wireless medias also. I mean, the properties of wireless media, first is the coverage area, the interference, the security, and the shared medium. These are the properties of a wireless medium. Coverage, effectively the coverage that the wireless signal can take care of in a particular area. Okay, the interference is, I mean, what are the things that are going to disrupt or interrupt the wireless signal coverage? We all know our wireless signal, some of these physical structures in the cities or towns will impede or deter the coverage area of the wireless signals. The security is another thing also. Trying to make sure there is security in the wireless signal is another concern. Shared medium, wireless LAN operates in half duplex, which means only one device can send or receive at the same time. Am I still online?
Well, you are online, don't go offline. Yourself, you're offline, but you're online.
All right. The types of wireless media, I mean, there are different standards of wireless media. Wireless media, you have the Wi-Fi IEEE 802.1 wireless. I think the last time we talked about them, where you have A, B, C, and G wireless media. You have the Bluetooth also, you have the WiMAX and the Zigbee. So you look at them, each of them at the same time. The Wi-Fi IEEE wireless is a wireless LAN technology. And the Bluetooth is a personal area technology. The WiMAX is used for point to multi-point. While WiMAX will cover a reasonable distance. For instance, let's say a distance of about 500 meters. It is used for point to multi-point or point to point. You know, like if you go to most of these Gamtel stations, you will see a big antenna, and then you will find a wireless access point there that can fire signal, let's say from Westfield to Tabokoto. You can use WiMAX technology in that. So you have this last one, Zigbee, is a low data rate, low power consumption communication, primarily for Internet of Things. Wireless LAN. In general, wireless LAN require the following. It will require an access point, and it will also require a wireless NIC adapter. Okay, I'm sure we all know what an access point is. Okay, I'm sure we all know what an access point is, and then it will also require a wireless network adapter. Let's go back. The wireless network NIC adapter provides wireless communication capability to network hosts. Okay. How many minutes do we have? Oh, I think we are done. We are able to cover it within the time frame. So this is an example. This is wireless. We talk about the physical layer. I'm sure the next time we'll be talking about the presentation layer. Okay. So thank you guys for today. What I'll need to do is I'll have to do a little bit of crimping and share it with you. And I'll also try to share the fiber optic cabling with you today. Okay.